Finally, for today, I want to go through the example I gave you with the quantum inspired standard form and try to derive also the Lagrangian, the dual from the Lagrangian, and see if it is the primal is feasible or the dual is feasible, strictly feasible, to see if we can assess strong duality or not. And so let's go for it. So first, have the indicator function of epsilon of x called w of x, which is equal to inf of lambda multiplied by w minus epsilon of w, and the second constraints being of x equal to 0 of x, which is equal to inf of y plus trace of yx. So if we rewrite the problem, have sep of x of inf lambda y brings equal to 0 lambda into r of the trace of Cx plus lambda multiplied by w and both stay on w plus trace of yx so it's equal to sub of lambda and lambda into r sub of x lambda into r y being equal to 0. And so, as before, well, I'm going too far into my steps. So if I respect the procedures, which is not really useful for aspects, but if we have the Lagrangian x lambda y, which is equal to the trace of Cx plus It's more normally because it's matrices. We don't put a scalar, but we put t. How did I make so when I had scalars on matrices? Or yeah, I put an index. But here we don't have index. So just say this. So plus tracer. Multiply matrices, we use the Frobenius scalar stuff, so I just this plus trace over t down value minus epsilon w plus trace of yx. So yeah. And so once you have this, you can write that sub of x and lambda into r widening into 0. So we have primal, which is inferior to n lambda r y0. Well, I skip steps because right, it seems we can factorize all by the trace. And x. Maybe I can put this out. Okay, I mistaken myself because w minus epsilon x minus x x sub of x And so of trace of TW, well, I skip a step. Trace of X multiplied by C minus T W minus T epsilon plus Y Y, or should I say maybe this would be more correct. Minus epsilon star of T and so which is trace of TW plus the indicator function of X plus the indicator function of C minus S of T plus Y equals 0 with the constraints on the Y. So we have this, and so it's equivalent to say that C minus this star of T is inferior to 0, so we define positive inferior to 0, and so that we have inf of lambda of trace of CW. That's it. No? Trace of CW. So this is this. Such that epsilon of 1 star of t superior to 0, superior to c, yeah. And so that's it. So we strong duality and put some relationship on the solution of the problem also. In particular, we immediately have the primal. So this, that goes to infinity. So it is invisible, it is unbounded, and the dual is also, it goes also to infinity. So it is unbounded until the primal is invisible from the dual, and the dual is invisible from the primal. So yeah, it's correlated to complementary slackness that we'll see in the next video. And maybe for the epsilon, because it was not maybe not really clear, what we did is that this plus the minus the trace of w uh, of, of t epsilon x but the trace of tx per epsilon x is just the same as this trace of epsilon star of t of x. So that's why, and so we can factorize by x this way and having this. So that's why we rated it like this. Okay. So maybe just ignore the red, just the final solution is this. And just just it's another thing after that I wanted to say that if the primal is go to infinity, then the dual is invisible because normally the dual should be superior to the primal. So, but infinity, how can you be superior to infinity? It cannot work. And same, so if the dual is go to minus infinity, then you cannot have the primal to be inferior to it. So it will be also a contradiction, and so um, optimal primal dual feasible points are necessarily related to each other in a way because of this. But yeah, the main point was about this, and I wanted to explain this epsilon star, and that's it.